Right. Interesting change I made. I rewired my exit coils in parallel instead of series. So my exit coils are cross connected in parallel. That's these two, and the two up here. It's a bit ad hoc at the moment, temporary wires, but guess what? It works a lot better. More output, more output, less input. So yeah, putting the exit coils in parallel basically increases my output and it reduces the drag even more. So yeah, because I was having to think earlier about when I tried the other exit coils that I rewound in the previous videos. A previous video, I I wound some new exit coils with thinner wire. Well, they worked worse. They weren't as efficient. It wasn't working so well. And I thought, hang on a minute. And I was thinking about that, and I thought, well, that means I need to make the wires thicker. And I thought, hang on, no, I don't even need to make the wires thicker. All I have to do is wire them in parallel, which is what I've done. So, wire them in parallel. Got more output, as you can see, and at 9 volts as well. Normally at this point I will be around 190 milliamps. At around 9 volts, 9.85 volts, around about that point there, I would be at 190 milliamps right now. So I'm actually gained an extra 60 milliamps by putting those exit coils in parallel, and it's actually drawing, yeah, let me see for yourself, 1.08 amps. We're running at, hang on, we're currently running at 13.82 volts at 1.08 amps. Actually, I can run it, I can slow it down a bit. Let's go down to 13.6. Right, we're at 13.6 volts now, which is what I was at. At that voltage, I'm at 1.06 amps, and the output is 240 milliamps. And we're at 10 volts. And I replaced the yellow LED with a red one. It's actually been a bit overdriven actually at the moment, but it's not too bad. Probably, it looks a bit too bright on the camera. I've got plenty more anyway, I'm not worried. The green one's not too bright. They're actually in parallel, back to back, so that they conduct AC. So when one LED's on, the other one's actually off, because they alternate with the AC. The resistors are getting pretty damn hot, I can tell you, at 240 milliamps. So the next phase will be to drop that resistor from, because I've got two resistors in parallel, it's at 5 ohms. I need to drop the value of that resistor down to 3.3 ohms, so that the LEDs don't get driven too highly, because the coils are in parallel, there's more current going through the LEDs and the resistor now. So I need to drop that resistor down to 3.3 ohms at some point. I haven't built the new board yet, which is what I'm going to be working on. I thought, well, there's no point rushing. I want to experiment with this first and find out the best configuration, and it'll help me to decide later. So yeah, we're making some interesting progress right now, and interestingly, my timing, using my little switch I made, I've had to move it one notch back, so we're not actually using this coil delay line at the moment, we're just using these. So actually, the higher the current, the less inductance I need, which kind of makes sense, because as the larger the current is across the coils, the more rapidly they will saturate, basically. So those, I can't measure the waveform on the oscilloscope in the center tap point on the exit coils now. I can't do that because they're in parallel. So what I've had to do is put the oscilloscope probe, connect it to one end of a leg, which is basically one of the outputs of the trigger circuit. That's why the waveform is different. So that pulse right there, this big spike down that goes down here, that's the triac that's triggered right at that point. So we get a big drop here, that's where it cuts the drag so much down. We get a bit of ringing on the end of the waveform as well. So that's the pulse we get. And in theory we should have lower voltage on the exit coil. Actually we don't. We seem to still have, yeah, it depends on which end I'm connected on the leg of that triac though, that's the thing. Output peak to peak 28.8, RMS 12.4, that's because the battery's been, it's all, the supercapacitors will be about 12 volts right now. So yeah, I thought I'd do an update on it. It's looking good. I mean, everything I've changed so far, everything that I've changed so far has made an improvement, and that's always a good sign, because normally if you change something and things start to go worse, you know you're going in the wrong direction. You've got to observe. You've got to observe these things and remember them to know how to make an improvement to something, because if you remember all the things you've tried in the past that have made an improvement, it's worth remembering those little things, because you can put them all together. It's a bit like a jigsaw puzzle. You need to put all the assets together to make something work more efficiently. Some people, they try something and they get a bit of a good result and they think, it's not working still, so they throw it away. Well, you shouldn't do that. You should keep all your assets in one basket, because when you're building and designing something, you never know when those assets will play a key part, a key role in making something work more efficiently. So as I say, at this time we should be at around 180 milliamps, and I'm actually 220. So it's definitely better than it was. I'm only going 1.2 amps, 1.02, so that's 1020 milliamps basically. So yeah, I thought I'd do an update. I'm actually winding coils at the moment, a new set of coils to go in there. I'll show you an update on this, on my coil winder. So this is my coil winder I made, and I'm actually in the process of winding a coil there, as you can see right now, using 28 SWG wire. I've got a bit of blue tack in there to grip it, to hold it in place. I actually wound one earlier today, 28 SWG. I put my coils in. I had some issues trying to push my coils in and out. Sometimes they go in. I've got some Captain tape on there. Sometimes I put the coils in, I can't get them out again. So what I've done is design an extraction tool. This is my extraction tool. So basically when the core won't come out of my bobbin, my extraction tool, I just put that on like that, put that on the bottom end. There's a little groove there for the wire to sit in, just there, and the wire sits in that groove so that I don't squish it, because this goes in a vise, and then I just squeeze it and it pops my cores out the bottom through there, so I can easily extract my cores when they get stuck in there. Sometimes the super glue, well, the acetone is sticky and it makes it so and the bobbins also shrink. They shrink slightly because of the tension of the wire, and you can't even get the cores out, so it's a bloody nightmare. That's why I made this thing, so I can just stick the whole thing in a vise and push them out basically. So a little update on that. So anyway, what are we at? Let me just put this on there. This fits like that. Push it right through actually. So at 220 milliamps. Well, it's gone down to 210 now. It keeps fluctuating because it's gaining speed all the time to keep up with the current demand. So it might go back up to 220 as it picks up on speed. Still better than it was. The voltage is 11.47, just got to 11.48. Yeah. Oh yeah, and I'm having some issues with this motor. The bearings are failing at this end. I think what happened is when I rewound the motor, I rewound it because it was drawing too much current. I don't want too much current to be drawn through it, so I rewound the commutator on it. I think what happened was I scratched. There must have been a scratch on the drive shaft, and it marred up the brass bushing on the bearing, and as a result, the bearings have just started to get eaten away. So what I've done is ordered some ball race bearings, and I'm going to change the bearing on the front of that. I'm going to with an 8mm drill bit, and I'm going to insert a ball race, and that should be in a couple of days. It should quieten it down even more. Because I was trying this other motor which I got from China, and this thing uses 3 times the amount of power that one does. And this thing, it might have more torque, but I don't really want all that much torque. I don't want to expend power for the sake of a bit more torque. I really want to cut down on power consumption. That's the whole point really. So I had this in, I was trying it out. It was using about 1.6 amps. This motor uses 1 amp, so that's the reason why I prefer this one. So anyway, when I get the bearing, I'm going to swap that out. And we'll see where we go from there. It should be more efficient, there should be less drag as well, because it's a ball race bearing I'm putting in. At one point the motor was getting so hot because it was drawing more current because of the less efficiency on my generator, but this thing's not getting as hot now, and I made this heatsink out of a piece of copper sheet. I basically cut this with I put thermal grease on the inside. I had this wrapped around the motor to keep it cool. Keep it cool. Sorry, I'm hiccuping now. But anyway, not much else happening. Oh look, we're at 1 amp now, look. That's not bad. Consuming 1 amp. We're still pushing out 200 milliamps. We would be around, at this point normally, I was around 160 milliamps. But now we're still pushing out 200 milliamps. That's a huge gain actually. our RPM is, yeah. So anyway, just a little update on the situation. And something else, I took my concentrics out the other day to try it without them in. Well, there's a lot less drag, it runs faster, I draw less current. Unfortunately, there's less output, which is due to the fact there's less flux flowing, and well, there's less drag, but there's less flux also. And my output was lower, something like, it was basically about half what it is. So, but I think if I was to take them off now, I think I'd be basically pushing out 40, 150. Yeah. The exit coils wired in parallel seems to work better, so I'm probably going to keep them like that. And my triac is cold. Store more energy in the capacitors to keep that triac triggered longer to improve the counter drag effect. Now another thing is, the more current you've got flowing, so when I put the bigger coils in there and they produce more current, it will also produce more counter drag as well. So it's a bit of a thing that goes backwards and forwards with it. Yeah, I mean you basically gain a little bit more on the exit coil when you put more load on it, but you still have an underlying drag effect which is still present, which is a problem. It's difficult because I mean basically I'm trying to use energy from the output to which goes in series. This board's in series with the exit coils, even though the exit coils themselves are in parallel, but they're actually in series through this circuit to the generator coils. So yeah, there was something else I was going to mention, I forgot what it was now. Yeah, well anyway, when I put the new coils on, the new generator coils, there's going to be more current flowing through the circuit, probably. There should be anyway. And that extra current, less voltage, it shouldn't matter too much to the exit coils, because now they're in parallel, they're more driven by the current through the circuit than they are through the voltage. I mean, there'll be a lower voltage across them now because these exit coils are in parallel anyway. So so now we're at we're nearly at 12.6 volts. Oh, it's speeding up. No, it's not. It's slowing down. Current just went up anyway. I'm not complaining. Current went up. Oh, input current's gone up slightly as well. We're at an extra 50 milliamps. So yeah, it's because my circuit wants retuning. But if I retune it, I'll probably lose that extra 30 milliamps on the output. Oh look, it's self-regulating itself. The circuit does seem to self-regulate itself. It seems to self-govern. So when it gets to a certain high speed, something snaps in the circuit and it pushes out more current, which is an advantage. It slows down, then the circuit counterbalances. I mean, look what's happening on the scope right now. The pulses are intermittently flickering on and off, which means it's in between optimum and less optimum. But when it's less optimum, it produces more power output, you see, but we have a bit more drag. So I could tune that out just by trimming this pot, but then we'll have less output on the meter. Let's just tune it a bit anyway and see what happens. You'll see what I mean. There we go, speeding up. Waveform's back to normal again, it's speeding up. And as it does that, our output drops as well. And our input is dropped. Yeah, it's I really need to tune this, optimize this setting for when the voltage is at the maximum preferred output voltage for charging batteries, for example. Once this is tuned properly, I had to retune it because I'd put these exit coils in parallel, and doing that changed some of the basics functionality of it, so I had to retune the trimmer pot to rebalance everything. Anyway, as you can see, the output's gone back down to 200 milliamps and the input's dropped to 970 milliamps. Anyway, so just a little update. I think that's it for now.